Hello everyone, my name is Collins Cheriot and I'm a data scientist. So today I'm excited to guide you through a project focused on survival analysis using the Kaplan-Meier estimator. That's a powerful tool that helps us understand survival probabilities over time. So survival analysis is a critical area in data science, especially in sectors where understanding the duration of time until an event occurs is essential. In healthcare, for instance, it allows us to gain insights into patient outcomes and assess the effectiveness of treatments. So by analyzing survival data, we can make informed decisions that can significantly enhance patients' care and optimize resource allocations. So some of the applications of survival analysis extend beyond healthcare providers, pharmaceutical companies, insurance companies, public health officials, and so forth. For example, in healthcare, the healthcare providers can utilize survival analysis to evaluate patient outcomes and refine treatment protocols. Also, pharmaceutical companies can analyze clinical trial data to determine the efficacy and safety of new drug. Survival analysis can also be applied by insurance companies to predict patient lifespans and enabling them to adjust policies and premiums accordingly. These can also be applied in public health officials by public health officials, in monitoring disease progression and allocating resources effectively. This method is particularly beneficial for healthcare professionals, researchers, data scientists, analysts, and policymakers who are involved in health data analysis, clinical research, or making informed decisions based on survival statistics. So normally by applying survival analysis, we uncover valuable insights that drive advancements in healthcare and other critical fields where time to event data is pivotal. So I now want to take you through this project where we used this type of survival analysis in predicting the likelihood of a patient to survive in a certain hospital. So we were given a data set, let's say for hospital B, that contains various columns and several data. So we are going to see this step by step. Let's dive into the coding process, and we start by installing the necessary packages. We have a BIP installed, Liveline, we have Livelines, Pandas, Nambi, and Matplotlib. So those are the essential, very important packages that we are going to use in this project. So this is how to import our Python, our libraries into the Jupyter Notebook for use in this project. Now we start by importing pandas, of which these are very essential library for data manipulation and analysis. It allows us to load, clean, and manage our dataset efficiently. Then we also have Nambi, which is a library for numerical computations, providing support for arrays and mathematical functions. We also have Matplotlib, that is used for creating static, animated, and interactive visualizations. So we'll use it to plot our survival curve that's at later stages. Then we have Livelines. This is a Python library specialized for survival analysis, which includes the Kaplan-Meier estimator and other statistical methods. So the next step is now to load the necessary datasets. So this is a Python code that is used to load our dataset into the Jupyter Notebook environment, and also we have this line of code that is df.head that is used for previewing the dataset to understand its structure. Yeah, so we start by loading our dataset and previewing the dataset structure that way. So when we run that Python code, you can see the outcomes. You can see the statistics of the loaded data. We have various columns, that is the name of the patient, age, gender, blood type, medical condition, date of admission, doctor, hospital, insurance provider, billing amount, a room number, admission type, discharge date, medication, and the test results. So those are the columns we have in our dataset, or the type of data we have in this CSV health dataset. Now, the next step in this project is now to pre-process the data. So in this step, we will convert date of admissions. You can see we have date of admissions here. Where is it? Yeah, we have date of admission, and then we have discharge date. Hope you can see the two. Now we are going to convert date of admission and discharge date to date time, so that we can use it in our time. We can use it in our next analysis. So this will allow us for accurate time-based calculations. So this is the code we are using to convert the date of admission to discharge date. That is data frame that way. And then the next step is calculating the duration. So we compute the duration of stay for each patient in days by subtracting the admission date from discharge date. You can see we have the admission date here, and then we have the discharge date. So we get the duration by subtracting this one. Of course, that's a simple mathematical calculation. Now the Python code that we are going to use in this case is that way. And then we can preview the updated data sets using that one, df.head. Let's preview to see the outcomes. Yeah, so you can see we have an updated data set where we have the duration has been included here, where we obtained it by subtracting the date of admission from the discharge, subtracting the discharge date. Yeah, subtracting this one, discharge date, and the date of admission, we get the duration. So you can see it's very simple. When you just have to write a line of code and it's able to do this. Yeah, this is how you update your data frame in Python when you are a data scientist. Now that is it. And because we are going to create we are going to use Kaplan-Meier filter, then it means we need to have a status column so that we know whether the patient was discharged from the hospital, or the patient may be died. So we need to print to see our columns, to see the data set we have, and this is how you will view it using this line of code in Python, that is print and then df.columns. So when you run it, you can see our dataset contains name, age, gender, and all those information. Now we can see the column which is named status. We don't know whether the patient was discharged or they died in the hospital. So we need to update our data frame by creating another column which is the status, and this is how we create it. So this column will indicate whether an event it will indicate a discharge, how the discharge occurred. So patient with a discharge date will have a status of 1, while those without will be marked as a 0 in this case. So this is how we are going to create our column. This is the Python code that we'll use. Let's try to run it and see the outcomes. So you can see here the status for all the patients is 1111. That means all the patients were discharged in this case. Now the next one will be the Kaplan-Meier survival analysis. So we want to perform Kaplan-Meier survival analysis. So with our dataset pre-processed, we can now perform this analysis using Livelines library that we've already imported at the initial stages. So we create an instance of the Kaplan-Meier filter. As you can see, we need to initialize the Kaplan-Meier filter, and this is the Python code that we are going to use. And then after that, we apply the filter to our duration and status data, and this is the Python code we use in this case, that is that one. And then next will be to plot the survival function. So we visualize the survival probability over time using matplotlib. That is a library used for visualization in Python. So this is a Python code that will be used to visualize the survival probability over time in Jupyter Notebook. So let's run our code and see the outcomes. You can see we have a graph that is the Kaplan-Meier survival curve, which is the survival probability against the number of days. So you can see from this graph we can derive our insights that the more the patient stays in the hospital is the lower their likelihood of surviving. So you can see the Kaplan-Meier survival curve, and in this case we've performed some survival analysis using the dataset we had. Yes. Now, to add more depth to our analysis, we can also stratify the survival analysis by a specific condition. This will be stratified, stratify the sample analysis by, let's for example do stratify the survival analysis by medical condition. So this is the Python code that we are going to use, groups.medical condition, that way. Yes. So we create an instance. This survival analysis by medical condition allows us to compare survival probabilities across different groups. For instance, we can see how patients with different medical conditions fare over time. So we start by grouping by medical condition. I hope we can see we have 4 conditions in groups. So we group by medical conditions, and then we identify the unique medical condition in the dataset, and then after that we fit and plot for each group. So we then fit the Kaplan-Meier model separately for each condition and plot their survival functions on the same graph. So this comparison can reveal differences in survival trends between conditions, as you can see. So when we run our code, this will be the output. Yeah, you can see we fitted the Kaplan-Meier model separately for each condition and plot their survival functions on the same graph. So this comparison reveals differences in survival trends between conditions. Like we can see the medical condition for cancer, obesity, diabetes, asthma, hypertension, and arthritis. So that is now for our deeper analysis. Then we can also go further to performing Cox Proportional Hazards regression. So when we perform Cox Proportional Hazard regression, we are going to use this line of code. So this will help us further understand the impact of various factors on survival. Yes, are we together? Yeah, so this model helps us identify the variables that significantly influence the hazard of the risk of an event occurring at a point in time. So we need to prepare the data set, and then we fit the model, and then we interpret the results, as you can see in this case. So the output of this Cox Proportional Hazards regression will be this way. Yeah, You can see that's the output. Model, we have that one, duration, status. Yeah, so when we run our code, that will be the output. We have gender, male. Yeah, so those are the statistical summary of the you know, the predictions. Then you can see from our box plots, we have the medical condition, hypertension, as that way. We have the age that way. Okay. Yeah, so this model summary provides coefficients that indicate the direction and magnitude of each variable effects on the hazard. So a plot of the coefficients helps visualize these effects, as you can see. So you can easily make the comparison, you know, to further understand the impacts of various factors on survival. Yes, so that's how we perform survival analysis using health dataset. So we've successfully conducted a comprehensive survival analysis using the Kaplan-Meier estimator and Cox Proportional Hazards regression. So we started from importing the necessary libraries and preprocessing our data. Then we moved on to visualizing survival curves of stratified by medical conditions to gain deeper insights. So the Cox model further helped us identify key factors influencing patients' survival, as you can see. So these are a Cox model further helped us identify key factors influencing patient survival. So this analysis not only enhances our understanding of patient outcomes, but also provides valuable information for healthcare providers, researchers, and policymakers. Yeah, it's a very important analysis for data scientists, especially those who will be working in hospitals, insurance companies, and others. So that is the video for today. Thank you for your attention, and I'm open to any questions that you may have. See you next time. I am Colin Steriot and I'm a data scientist. Goodbye. See you in our next video. Subscribe.